To show the geometry of some simple molecules, let's use balloons to represent electron pairs. We can start with a molecule with 6 electron pairs around the key atom. An example of this would be sulfur hexafluoride, or SF6. In SF6, all 6 pairs of electrons are bonded to 6 fluorine atoms. This molecule can be represented by 6 balloons tied together, or the equivalent plastic stick model. At its center is a sulfur atom. The balloons are furthest away from each other when they are oriented along the x, y, and z axis of an octahedron. Because all bonds are identical and oriented symmetrically in space, the molecule has a uniform electrical charge distribution. Each SF bond is polar. Since the center of negative charge coincides with the center of positive charge, the molecule as a whole is nonpolar. If atoms bonded to the key atom are not identical, the molecule may be polar. We say that a dipole exists. The sulfur chloro pentafluoride molecule, SF5Cl, is polar as a result of the unequal attraction of chlorine and fluorine atoms for electron pairs. For a molecule with 5 bonded electron pairs and a non-bonding electron pair, we can use IF5 as an example. A white balloon will represent the non-bonded pair of electrons, and a pink balloon will represent the bonded pairs. The 6 balloons still take on an octahedral geometry, but the 5 electron pairs bonded to the fluorine atoms take a square pyramid geometry as the iodine atom positions itself at the center of the square base. There is a lone pair below the base of the square pyramid. All the 5 fluorine atoms are on one side of the molecule. This makes the molecule slightly polar. Remove one balloon from this model so that only 5 balloons remain. When all the electron pairs are involved in bonding, the molecule is most stable when the geometry is a trigonal bipyramid. An example is PCl5, or phosphorus pentachloride. The shape is that of 2 pyramids joined at the base with a key atom at the center. Even if each PCl bond is polar, PCl5 is nonpolar because of symmetry in the molecule. This model represents a molecule with 4 bonded electron pairs and a lone electron pair, such as tellurium tetrachloride, TeCl4. 5 electron clouds still form a trigonal bipyramid. Since one trigonal corner is empty, the molecule takes the shape of an irregular tetrahedron.